Hello friends, here in this video we will see a problem of shaft based on rigidity criteria, and for that purpose here we have a question. Let's read what is given here. A solid steel shaft transmits power of 20 kilowatts at 500 rpm. If maximum torque exceeds mean torque by 30%, calculate the diameter of shaft. The shaft is subjected to a twist of 1 degree in a length of 2 meter. Take capital G is equal to 0.84 into 10 raised to 5 Newton per mm square. Now this is the question which we have. Whatever is given in this question, here I will write that in the form of data. Now, at first I'll write the type of shaft. Type is solid shaft. A solid steel shaft transmits power of 20 kilowatts. So power is given. P is equal to 20 kilowatts. It means it is 20 into 10 raised to 3 watts. Next, at 500 rpm, so speed N is equal to 500 rpm. If maximum torque exceeds mean torque by 30%, so here T max is 1.3 times of T mean, since it is exceeding 30% the mean torque. Next, calculate the diameter of shaft. So this is the question. Here we have to find how much the diameter of shaft is there. The shaft is subjected to a twist of 1 degree. So theta is 1 degree, which we have to convert it into radians. So it is pi by 180 radians. In a length of 2 meter, capital L is equal to 2 meter, that is 2000 mm. Take G, that is modulus of rigidity, 0.84 into 10 raised to 5 Newton per millimeter square. Now this is the data which we have. See, this is called as rigidity criteria, and that we can find out by two terms. In rigidity criteria, first of all there will be modulus of rigidity, capital G. In sometimes it is also denoted by capital C as well. And we have to look for another thing in rigidity criteria, that is angle of twist. Here it is 1 degree. So these two things decide that the problem is based on rigidity criteria. That is, first of all, modulus of rigidity value. Second, angle of twist. If both of them are there in the question, it means the problem is based on rigidity criteria. So now, let us get the solution for this problem. First, I'll draw the cross section of the shaft. It is circular and solid. Its diameter is capital D, that is what we have to calculate. Now this shaft is subjected to a torque which causes its rotation. That torque will be maximum torque, because while designing the shaft we have to consider maximum torque. Next, here in this case angle of twist is given. Angle of twist, I can explain it on this diagram. That suppose we have point A at this location, and if there is twisting, this point A will get shifted. Now suppose it is here, which is A dash, that is a new position of point A. So this is called as angle of twist, and this twist is uniform throughout the length. Now I'll start this problem by saying that since power transmitted by shaft is given by, the formula of power transmitted is P is equal to 2 pi nt upon 60. Next, therefore we can say that since we want to find torque, I'll keep T on one side, and this would be P into 60 upon 2 pi n. I'll put the values. Power, it is 20 into 10 raised to 3. Speed is 2 pi into 500. So from this, the torque value which I have, my answer is, it is 381.97 Newton meter. Now this torque is nothing but the mean torque, or we can say average torque. Now after this, I can say that hence T max, that is maximum torque, the relation is given, it is 1.3 times of mean torque. 1.3 into T max, that is equal to 1.3 into, it is T mean, not T max. Here we have T mean because T max is 1.3 times of T mean. Actually this is T mean. This value of T mean is 381.97. so I'll write the answer onto the next page. So T max comes out to be 496.56. it is in terms of Newton meter. Now the torque which is there in Newton meter, we will convert it into Newton mm because we want the diameter of shaft in terms of mm. So this will be 496.56 into 10 raised to 3 Newton mm. Now after getting the value of maximum torque, now we can go for rigidity criteria. I'll say that since by rigidity criteria, in rigidity criteria we have the formula as T by J is equal to G theta by L. So therefore this value of T, it is nothing but T max, which is 496.56 into 10 raised to 3 Newton mm. J is polar moment of inertia. For a solid shaft it is pi by 32 d raised to 4 is equal to, modulus of rigidity is 0.84 into 10 raised to 5 given in the problem. Theta is in terms of radian, that is pi by 180, and the length of the shaft, it is also given, that is 2 meter, or we can say 2000 mm. So I'll keep the value in mm. Now we want d raised to 4, so I'll shift all the terms on one side and d raised to 4 will be on the other side. So how this happens is that I'll shift d raised to 4 on this side, bring all terms here. So it will be, therefore d raised to 4 is equal to, it is 496.56 into 10 raised to 3 multiplied by 2000 divided by pi by 32. No, it is pi by 32. I will shift this entire term in the denominator here. So I have 0.84 into 10 raised to 5 multiplied by pi by 180. Now the calculation has become really simple. We can calculate it in one single step, that is numerator divided by this denominator. We will get that as the answer of d raised to 4. Now we don't require d raised to 4, so what we have to do, whatever things we are getting here, we have to take the square root twice. That is, I would be taking the square root of this answer twice, and then I will get the value of d. And so if I calculate it in this manner by taking the square root twice, my answer of diameter comes out to be 51.25 mm. Now remember, in case of shafts, the diameters which we have to round it off. That is, we cannot keep the diameter in terms of this decimal value. We have to round off the values. And if the shaft diameter is 50 mm, then the range which we have, if it is in between 50, then the range is from 50 to 55 mm. That is, it is 50 to 55 mm. So if our answer of diameter lies between this, then we have to select the next higher value. That is, our answer is 51.25. So here I will select the shaft diameter as the next higher value, which is 55 mm, because these are the steps. In case of shafts, from 25 mm to 60 mm, the steps are of 55 mm. So after 50 mm, the next higher diameter is 55. My answer is 51.25. I'll say that is equal to 55 mm. So this is our answer. It means, based on rigidity criteria, the shaft which we have designed, its diameter, it comes out to be 55 mm. So as we see in this question, the problem was based on shaft which was designed by using rigidity criteria, and in this they were telling us to calculate the diameter of the shaft for the power requirement of 20 kilowatts, speed 50 rpm. Condition was given that maximum torque is exceeding the mean torque by 30%. Then the angle of twist, length of shaft, and modulus of rigidity was given. So based on all these conditions, we have to find the diameter of shaft which satisfies all these conditions. So the diameter of shaft is 55 mm, which is satisfying these conditions, and here we have designed a shaft based on rigidity criteria. And with this we complete the question.